And now we get to continue the journey. So we solved quadratic equations using our four methods. Then we solved formulas for a specified variable. And now we get to solve applications. So I've chosen just a couple. I wanted to do the area questions, but the ones for this section just went crazy. So we're going to do two types. The first type is going to be solving applied problems using Pythagorean theorem, and then the next video will be the next type. So in the question, you'll see something about a right triangle. So for this one, it says one leg of a right triangle is 4 centimeters longer than the other leg. The length of the hypotenuse of the triangle is 12. Find the lengths of the two legs. Solve to one decimal place if necessary. So what you're going to do is you're going to draw yourself a right triangle. Now, if you don't know the parts of a right triangle yet, the important part is that this is your hypotenuse. So the length that's across from your right angle is always your hypotenuse, and then the other two are considered legs, and it doesn't matter which leg is which. So this says that one leg of a right triangle is 4 centimeters longer than the other. So if I let one leg be x, the other one is 4 centimeters longer, which would make it x plus 4. Then it says the length of the hypotenuse is 12. Oh, that's nice. Find the length of the two legs. So what you'll do first is you'll always set up your right triangle. So you'll always have an x, and either all three sides will be in terms of x, or maybe one of them will be a number, and then 100% of the time you set up Pythagorean theorem. Pythagorean theorem is that a squared plus b squared is equal to c squared, where a and b are your two legs and c is your hypotenuse. So we'll call x a, and we'll call x plus 4 b. It doesn't matter which one's a and which one's b. The thing that matters is that your hypotenuse is c, so it's going to equal 12 squared. So now this is set up. This is our quadratic that we have to solve. So we have four methods. We can solve by factoring, we can square root method, complete the square, or quadratic formula. But no matter which method you choose, I can't start yet. I need it to be in standard form. Ax squared plus bx plus c equals 0. So the first thing we have to do is simplify. So I'm going to multiply x plus 4 by itself. So that's x plus 4 times x plus 4. I'm going to square 12. Then I'm going to expand this. So I get x squared plus, so x times x is x squared. X times 4 is 4x. 4 times x is 4x, and 4 times 4 is 16. Then I'm going to collect like terms, and I'm going to subtract 144 at the same time. So I end up with 2x squareds plus 8x minus, I don't know if I trust myself. I think it's 128, but, good. Now this is the quadratic I'm going to solve. Now I could solve it right now, right? I could square root, I could check to see if I can factor it, square root method or property, complete the square or quadratic formula. But I also noticed that I could take out a 2. Now, up to you. You can greatest common factor out the 2 out of everything, or because it is an equation equal to 0, I can actually divide everything by 2, and that is going to make this easier. So let's go x squared plus 4x minus 64 is equal to 0. Whew, that's a nicer quadratic equation. So now I get to choose. Do you want to factor? Well, do you want to think of two numbers that multiply to give me 64 and add to give me 4? Maybe. Although whenever it says this to me, solve to one decimal place if necessary, I'm always like, maybe this one's not going to be great. So you could try factoring, but I don't think this one does. Square root method you can't do unless you've completed the square first. So now we're down to two options: complete the square or quadratic formula. Now since we did quadratic formula most recently, I'm going to complete the square. So to complete the square, I already have a 1 in front of the x squared term, so I'm good to go. So I'm going to take half of my middle term, and I'm going to add it and square it and add it and subtract it. So I'm finding my magic number. So half of 4 is 2, 2 squared is 4. So I'm going to add 4, I'm going to subtract 4. Now, this is my perfect square trinomial. There's no number out front to pay a toll, so I'm just going to factor that as x plus 2 all squared. And then minus 4 minus 64 is minus 68. Oh, I should have given myself another page. I'm going to take this up over here. So now I'm at x plus 2 all squared minus 68 is equal to 0. So to solve, I'm going to use the square root method, or property. I'm going to isolate my square, right? I added 68 to each side. Then I'm going to take my square root, so x plus 2 is equal to plus or minus the square root of 68. Then I'm going to minus 2, and I get x equals negative 2 plus or minus the square root of 68. Normally when I solve, I have to then look to see if I can simplify my radical. Because this one says that I can solve to one decimal place, I don't have to simplify my radical. I've got two solutions. X can be negative 2 plus root 68, or x can be negative 2 minus root 68. If I plug these into my calculator, what do I get? And again, I can round to one decimal place. So I've got negative 2 plus root 68, which gives me 6.2. And I've got negative 2 minus root 68, which gives me negative 10.2. Now, I'm going to reject the negative answer because I can't have a negative length for a triangle. So I know that x is 6.2, so therefore my two legs would be 6.2 for this one, and then this one's going to be 6.2 plus 4, which is 10.2. So you can put your answers up here. Mine got a little bit messy. I feel like I'm going to have to change my notes. Okay, but I could say, therefore, the legs are 6.2 centimeters and 10.2 centimeters. Awesome. All right, so that's a me do. This is potentially a you do. So for this one, instead of giving you those sentences, like one leg is 7 centimeters or 7 centimeters shorter than the other leg, and the hypotenuse is 2 centimeters longer, or something like that. I could have done that, but what I've done is that part for you. I've set up your triangle with your expressions on each leg and hypotenuse. So what you're going to do is set up Pythagorean theorem, and then you're going to make it into a quadratic that you can solve. So you're going to start with x plus 2, well, depends how you want to set it up. Let's say do it the same as the other. So if we do a squared plus b squared equals c squared, I was about to do c squared equals a squared plus b squared. So let's do these two. So the legs squared. So x squared plus x minus 7 squared is equal to x plus 2 squared. All right, pause the video. Try this one. So I want you to expand these brackets. When in doubt, I seriously, putting this step in of the x minus 7 times x minus 7, take the time, do it. I see this mistake all the time. So I've distributed, now I'm going to collect like terms. Then no matter which method I'm going to use, I'm going to put everything to one side. So I'm going to minus the x squared. I'm going to minus the 4x. And I'm going to minus the 4. That'll leave me with x squared minus 18x plus 45 is equal to 0. Okay, you get to choose. Do you want to complete the square? Which you can. This nice middle term is even. So you can complete the square, or you could use the quadratic formula, or are there two numbers that multiply to give me 45 and add to give me 18? I'm doubting it. I don't think you can. Oh, you could. This one's factorable. So I'm going to say pause the video. This one you can solve by factoring. You could complete the square, or you could use the quadratic formula. It does not matter to me. On a word problem, I will never specify what you have to do. You get to choose. So either complete the square because it's good practice, or factor because it's quick, or quadratic formula because it works every single time. You choose. Now, oh no, what were my numbers? 45 divided by... I found that the two numbers that multiply to give me 45 and add to give me negative 18 are negative 15 and negative 3. So I'm going to factor. X minus 15, x minus 3. So I end up using my zero factor property with x equals 15 and x equals 3. And again, if you complete the square or use the quadratic formula, we're going to get these exact same answers. Then the question said, find the lengths of the triangles. So we've got three lengths. We have x minus 7, we have x plus 2, and we have x. I wrote that in a weird order. So let's put in x is 15. If x is 15, then this length would be 15 plus 2, which is 17. And if we did 15 minus 7, we would get 8. So for this scenario, my side lengths are 8, 15, and 17. Now we have to do it again. So my other option is, because there's no reason to reject the 3, it's not negative, so we have to put it in again. So if I put x is 3, my other side length is 3 plus 2, which is 5. But then I've got 3 minus 7 is negative 4. I can't have a negative length, so I'm going to reject these solutions. And my only solution is 8, 15, and 17 are my side lengths. Okay, so that is the Pythagorean theorem application.